Hello, this is Jeon Parjung. This course is data modeling and remote control for networks and security. Today we will study OpenStack Based I2NSF Framework. I2NSF stands for Interface to Network Security Functions. Okay. Introduction to Interface to Network Security Functions. The background is that flexible and scalable provisioning of security services in network functions virtualization like NFV is required. Also, efficient leverage of physical network functions and virtual network functions are needed. Finally, efficient security task processing in NFV along with software-defined networking like SDN is required. We had motivation for I2NSF almost 9 years ago. ITF means Internet Engineering Task Force. They launched a new working group called the I2NSF working group, aims to make standard interfaces to network security functions. Okay, it is called I2NSF for cloud-based security system. I2NSF working group defines a framework and corresponding interfaces to control and manage network security functions and NFVs on top of SDN and NFV environment. Okay. The I2NSF is good for cloud-based security services. Cloud-based security service system with I2NSF. I2NSF allows heterogeneous NSFs from multiple vendors to efficiently work for users' security policies and requirements in a cloud system. The I2NSF security system can support the various domains such as vehicular IoT, Internet of Things, or smart node, smart home, smart company, smart campus, cellular networks, and data center. I2NSF security system, the following technologies are leveraged for the I2NSF system. The first one is SDN, software defined networking. Second one is SFC, that is service function chaining. The last one is NFV, stands for network functions virtualization. This figure shows I2NSF framework architecture. Basically, top one client system called the I2NSF user, and the management system has the main brain component is a security controller, and then developer management system provides a security solution, and I2NSF analyzer is the machine learning component for data analytics for I2NSF. And the bottom we have a security network having various network security functions like firewall, web filter, deep packet inspection, antivirus. Okay. And then those cloud-based security system can secure the connection between client and server. I2NSF framework has several interfaces. The first one is a registration interface. Second one is a consumer face interface. Third one is NSF facing interface. The first one is monitoring interface. The last one is analytics interface. Okay. So basically, the consumer-facing interface is interface between user and security controller, deliver security policy to security controller. And then NSF facing interface is used to deliver the low-level security policy translated from high-level policy delivered over consumer-facing interface. Okay, and the monitoring interface is used to collect monitoring data from various NSF. This guy performs machine learning and then make a report and then deliver that report feedback message over analytics interface to security controller. Okay, and the registration interface is used to register the capability information of NSF with security controller. Okay, so we can extend I2NSF framework with the SDN. So you can see the upper one is I2NSF framework, lower one switch controller is SDN controller, and SDN controller governs multiple SDN switches like OBS, open flow switches. Okay. So this figure shows SDN network governed by I2NSF framework. Okay. So basically, security controller gives low-level security rules over NSF facing interface to SDN controller. SDN controller governs switches. Okay, and so like OpenFlow protocol is used to enable OpenFlow table to provide the simple firewall services. Okay. The second one is service function chaining, SFC. So right hand side we have a figure. So multiple NSF are chained using service function chaining. So classifier and make some service function paths for specific traffic flow, and this security function forwarder, okay, or service function forwarder, according to the SFC, the header, and select next hop network security function accordingly. Okay. The third one is NFV framework for I2NSF. Okay, so this is ETSI, European Telecommunications Standards Institute, NFV architectural framework. We can implement I2NSF on top of NFV. So, okay, on top, here, top one, this is dashboard, operating support system and business support system for I2NSF user. And security controller and the vendor management system can be implemented over element manager. And network security functions can be implemented over virtual network function, VNF. Okay, so the VNF are managed by VNF managers, and the NFV orchestrator manages network service, having a chain of network security functions, also governs NFV manager and virtualized infrastructure manager, VIM. And then lower, this one is NFV infrastructure, provide virtual compute, storage, and network resources for VNF. Okay, and then virtualization layer like hypervisor make these virtual resources using hardware, compute, storage, network resources. Security policy translation is important function for I2NSF. Okay, so the objective is it aims at the specification of a scheme of security policy translation. That is a security policy translator in interface to network security functions I2NSF framework. This security policy translator enables an intent-based security service in the I2NSF system. Basically, high-level intent given to I2NSF security controller, it can translate low-level security policies that is rules to configure corresponding NSFs, okay, for required security services. So document is this draft, okay, Young I2NSF security policy translation, okay. You can click, you can get the latest version of this document, okay. So this is individual draft, okay. So necessity for policy translator, policy representation according to I2NSF user. So basically the high-level policy like block my son's computers from malicious websites like some gaming website. So drop package from the IP address 10.0.0.1 and 10.0.0.3, okay, toward the malicious website like ham.com and illegal.com, okay. So even if I2NSF user gives the first high-level policy like this second a little detailed policy should be generated, okay. So this figure shows security policy translation procedure, okay. So I2NSF user giving high-level policy. This one is scenario is time-based web firewall service for SNS services at company, okay. So during the work time, employee cannot access SNS website, okay. So timing information, this one scenario is we skipped, okay. We focus on source and target translation. So high-level policy for employee SNS access policy given to security controller. Security controller delivers that policy to security policy translator. So this translator consists of 3 steps: data extractor, data converter, and a policy generator, okay. So data extractor performance extraction of meaningful data from high-level policy like a source, employee, destination, SNS website, and the action is dropped. And step 3, convert this high-level employee SNS data convert into low-level data like source, employee, IP addresses of employees' machines, right? 10.0.0.2, range is 10.0.0.10. And destination SNS translate into specific Facebook, Instagram URLs, okay? Drop is the same. And for this kind of conversion, security capability and custom data stored into database. So we can using this capability data, we can select appropriate NSF for this network service, and custom data is used to translation high-level the source and destination information, okay? And then policy generator making low-level policy written in the XML file, okay? And then delivered to appropriate network security functions, okay? Over NSF facing interface. This is an example translation architecture. So high-level policy given to policy translator. So previously we saw, right? So data extractor, data converter, policy generator, contacting NSF database for translation, okay? So high-level policy like my son's PC cannot access malicious website. So this high-level policy translate into low-level policy like my son's PC. It translates is my son's devices IP addresses, and the destination malicious website translated into specific ham.com malicious and illegal.com. So we saw I2NSF technologies, okay? From now on, I will explain ITF standardization of I2NSF. Interface to network security function I2NSF, okay, a working group. So the working group, I2NSF working group, the goal is to standardize cloud-based security service systems. I2NSF working group was established in 2015, okay, 8 years ago, and is closed in 2023. Main contributors are SKKU, Huawei, and Telefonica in Spain, and the working group chairs are Linda Dunbar and Yob Neer. Main editor is Jean-Paul Zhang at SKKU. This is me. This is a website of I2NSF working group. So I2NSF working group published 3 RFCs. The first one is RFC 8192 about the interface to network security functions, I2NSF problem statements and use cases. Second one is RFC 8329 about framework for interface to network security functions. The last RFC 9061 Yang data model for IPsec flow protection based on software-defined networking SDN. Also, we have several working group documented. All here 6 draft approved as RFC. So I am editor for those 6 RFCs. Okay, documents. So those 6 internet drafts approved as RFC. Okay, so this year 2023 they will be published as formal RFCs. Okay, so the first one is applicability of I2NSF to network-based security services. Second one is I2NSF capability Yang data model. Third one is I2NSF consumer-facing interface Yang data model. And first one is I2NSF network security function-facing interface Yang data model. Fifth one is I2NSF registration interface Yang data model for capability registration. And the last one is I2NSF NSF monitoring Yang data model. So we have also several individual drafts. So those drafts will be reviewed as RFC through independent submission, especially 2 draft security management automation of cloud-based security services in I2NSF framework. This is for intent-based networking with closed-loop security control. And second one is I2NSF analytics interface Yang data model for closed security. Okay, closed-loop security control. Okay, and the other internet draft are just for information. The first one is the guidelines for security policy translation in I2NSF. The second one is I2NSF security controller facing interface Yang data model for cross-domain IPsec flow protection. In order to proceed with the I2NSF standardization, we engaged in I2NSF hackathon project for ITF hackathon. So this is ITF hackathon. Basically, many people gather together, individual working groups working for the hackathon project to prove their concept. This figure shows the poster, our I2NSF 108 hackathon project. Okay, this hackathon project, we reflected the latest revision of the following draft with the OpenStack Based I2NSF system. Capability data Yang model, consumer facing, NS facing restoration interface, and the security policy translation. So restoration of I2NSF framework on top of OpenStack. Left hand side, we can see the network topology for hackathon project. Okay, so this one is I2NSF user. This is a security controller. This is developers management system DMS, and this is the security network having firewall and the web filter. And this is employee system. This is a data network internet. So open source here from OS, CompD for netconf, and this one is MySQL for database. This OpenStack. The Suricata for this one is the open source for time-based firewall and web filter, and this is LastConf. Okay, and the minimum specification for OpenStack. This is RAM storage CPU. Okay. This is the video clip for demonstration for I2NSF hackathon project. So you can click. This is collaboration work with ETRI and SKQ. This is open source project for I2NSF hackathon project. Okay. So this is our previous hackathon snapshots, ITF 103 hackathon project. Okay. So we got the award. So one of the top 3 teams selected among 21 teams. Okay. So in the middle, he is the Charles Eccles. He is hackathon chair. Okay. So let me give one presentation for ITF 110 hackathon project. Okay. So this project held March. Okay, 1 through 5, 2021 during the COVID-19 area. So we participate in hackathon online in Busan, Korea. So I was a champion for this hackathon project. This is a poster for hackathon project ITF 110. So this one is I2NSF architecture in NFV reference framework. In the middle we have logical framework for I2NSF. The bottom one is I2NSF hackathon network topology. So left hand side the participants for this I2NSF hackathon project. Right hand side we have source code and the video clip, and so development environment and the manual and the content for this hackathon project. Okay. So hackathon plan, the implementation of the internet draft for the I2NSF system for cloud-based security services. So we used those draft. Especially we updated to underline the draft. Okay. So implementing application or analytics interface for delivering feedback from I2NSF analyzer to security controller. So the basic idea is this hacker or attacker, they perform denial of service attack, and then I2NSF analyzer collect the data and then detect attack from this DOS attacker. So this the slide shows NSF monitoring using I2NSF monitoring interface via netconf. Okay, so subscription based NSF monitoring. So this one is monitoring NSF resources. Okay, this one is monitoring DDoS attack snapshot. So we implemented application interface that is analytics interface. Okay, so we monitor data using monitoring interface. We collect monitoring data and analyzes the data using machine learning, and then it deliver the feedback information as a report to security controller, and then security controller reinforce. Okay, and then apply the reported reconfigured or feedback information into NSF. Okay, so NSF sends monitoring data to analyze via monitoring interface such as DDoS detection report, and the analyzer creates a new policy based on the received data through machine learning. And step 3, analyzer sends the new policy to security controller via application interface. And step 4, security controller translates a high-level security policy of application interface to a low-level security policy of NSF-facing interface. And step 5, security controller sends the new low-level security policy to NSF via NSF interface. Step 6, NSF enforces the requested security policy. While we learn the draft NSF monitoring data model may be extended for monitoring packet flows in NSF to detect DOS or DDoS attack. The monitored packet flow data can be useful to protect the I2NSF framework. Also, the feasibility of application interface, that is called analytics interface in I2NSF framework, is demonstrated for security management automation for closed-loop security control. Next step, extension of the monitoring YANG data model to monitor packet flow, and the usage of S-flow for network traffic monitoring. The NSF will be used. The improvement of I2 NSF analyzer with machine learning to update and create a security policy. And also we extend I2 NSF to support automatic update of the service function paths of NSFs for new security policy. And also we will enhance security policy translator for security management automation. Okay, this is I2NSF open source project at GitHub. Okay, so this is URL of our I2NSF framework project. This is the final level slide having our team members and snapshot. My PhD student, Patrick Lingar. Okay, so this shows sponsors for our I2NSF project, NRF, National Research Foundation Korea, IITF, Institute of Information and Communications Technology Planning and Evaluation, and TTA, Telecommunications Technology Association, SKKU, 성균관 University, Sungshu University, ETRI, Electronics and Telecommunications Research Institute, and ITF Middle Forum. So from now on, I will explain installation of I2NSF into OpenStack. OpenStack based I2NSF framework setup. The employee example with the security controller, DMS server, and I2NSF analyzer in ITF 110 I2NSF hackathon project uses Ubuntu 16.04 cloud images. You can download the image from this and upload the image to OpenStack using this command. And secondly, set up security groups in OpenStack so that instances can connect to the internet. Okay, so you can using this, okay, set up security groups. And this shows the I2NSF topology. Okay, so I2NSF user, and this is security controller, this is DMApps, this is I2NSF analyzer. We have two security functions, time-based firewall and web filter. Okay, and this is DDoS attacker. This is open source for our system environment, and this minimum specification for OpenStack. So according to this installation, the first create a security controller instance using Ubuntu 16.04 cloud image using this the Nova command, and then allocate the floating IP for security controller using OpenStack server add floating IP, and the security controller floating IP address is used. And access the security controller using SSH secure shell using SSH, and then using qpair pass Ubuntu at the controller floating IP address, and then download the security controller source code from GitHub. So from our I2NSF framework project, you can download source code, and update advanced package tool using sudo apt-get update, and then install package. So using this command, and install compd. So you can using this compd, you can use netconf protocol, and edit the service Python file with proper IP addresses. And then step 9, edit registration in the file ITF I2NSF registration interface with the security controller IP address. And then step 10, extract the jetconf.tar in security controller web version 2 using this command tar. You can untar. And then install jetconf using this command. Activate on I2NSF web server for a user. So you can using this command. And then DMS server. Create DMS server instance using Ubuntu 16.04 cloud image. Using Nova boot, and allocate the floating IP address for DMS server, and then access the DMS server using SSH, and then download the DMS server source code from GitHub from I2NSF framework, and update advanced package tool using sudo apt-get update. And DMS server also install packages according to this command, and install compd, and edit DMS server this Python file with the proper IP address. And then we needed to install I2NSF analyzer. First of all, create a new instance for I2NSF analyzer using OpenStack Nova command. And then allocate the floating IP address for I2NSF analyzer, and then access I2NSF analyzer using SSH, and download the DMS source code from our I2NSF GitHub project, and update advanced package tool. Sudo apt-get update, and then install zip and Python 3 that's the pip with apt using this command, and then unzip the file, analyze the zip, and update the pip Python 3 pip installation performed, and then install Python libraries using this command. And then employee example for testing. So first of all, create employee instance using Ubuntu 16.04 cloud image using this Nova command. Allocate the floating IP address for employee, and access employee instance using SSH. Use the X11 forwarding to use graphic user interface GUI using this SSH command. You can access. And open a web browser like Firefox. You can sudo apt-get install Firefox, and then you can execute the Firefox as a web browser. In the OpenStack server, check port list and copy the ID of unemployed port. So report to this figure. And then edit vnffg test YAML file with the port ID of employee. So you can using this snapshot. So you edit accordingly. And then DDoS attacker. So first of all, create a DDoS attacker instance using Ubuntu 16.04 cloud image, and then allocate the floating IP addresses for DDoS attack instance, and then access employee instance using SSH. Okay, this one DDoS. Okay, instance. Okay, and rather than employee DDoS instance. Okay, install packages. Okay, using this command, and then install SKF py Python library. Okay, and then we can install time-based firewall. Create the time-based firewall instance using Ubuntu 16.04 cloud image, and then download the repository from GitHub, and then move a time-based firewall to your home, okay, Ubuntu directory, and run install.shell file, and wait until installation finished. And after that, init edit init send the IP Python file according to the purple IP address, and create an image snapshot from OpenStack server, and create a VNFD in OpenStack server using this tacker command. Okay, and then URL filtering. So create the URL filtering instance using Ubuntu 16.04 cloud image using Nova command. Download the repository from GitHub. Okay, and then move URL filtering to your Ubuntu home, okay, directory. Copy the image, okay, the files into your home directory, and then run install shell file, and then wait until installation finished, and then edit init the send IP Python file according to the purple IP address, and create an image snapshot from OpenStack server, and create the VNFD in OpenStack server. And then operations, start the security controller. So you can using this command, you can start, and then run DMF server using this command. You can start DMF server, and then you start socket for OpenStack. Okay, using this Python OpenStack server Python file executed, and then run web-based I2NSF user. So you can using this I2NSF user. Okay. And register user group and URL website. Okay, using this front end website, you can register employees IP address. Okay, start and ending the range of IP addresses, and then the SNS website, you can enter specific URLs, Facebook and Instagram, and then enter the configuration. Okay, this is time-based web filter. So the policy name, this is a rule name. Okay, security policy for blocking SNS. This is block access to SNS during office hour. So employee source and destination is SNS website. The starting time, the ending time, this is only once. So, and then open on employee web browser and try to connect to SNS website. And then employee instance should not be able to connect to Facebook, Instagram, because we performed security policy, time-based, okay, firewall and web filter. And step 9, analyzer CLI command line interface. Okay, so edit the subscribe time, firewall, Python file, and subscribe URL filtering Python file with the purple IP address using this list. Okay, you can check a file URL filtering. This, okay, network, this is a time-based, okay, firewall, this network. So step 10, subscribe to each. Okay, so each NSF. So using this command, you can subscribe each NSF. Okay, time-based firewall and URL filtering, your URL filter. And step 11, try stress test on each NSF to generate notification like DDoS attack. Okay, so in DDoS client, edit the attack Python file to purple IP addresses, and this is actual DDoS attack. Okay, so Python 3 attack.python, And then after detecting the attack on NSF will report to the I2NSF analyzer, and the I2NSF analyzer creates a new policy to block the attack. So terminate after this DDoS attack scenario, you need to terminate all I2NSF components. First of all, security controller can terminate it using clean security controller, and DNS case in DNS console you can press Control plus zip file, terminate your terminal, and the OpenStack case of Python clean.py Python file, and the I2NSF analyzer, just I2NSF analyzer console, you can press Control and C button, and the DDoS attack case also Control C and C. So this is the GitHub for I2NSF project. Okay, you can download our class, and this is video demonstration, and for our I2NSF class. In conclusion, in this class we learned the following: I2NSF interface to network security function for cloud-based security services. We learned the installation and operations of I2NSF on OpenStack. I2NSF framework can be implemented with the SDN, NFV, SFC, okay? And then I2NSF framework can work well in OpenStack based NFV, network functions virtualization environment. We believe SKKU I2 Lab has led the standardization of I2NSF in ITF. We finished all 6 observability and young data models for I2NSF. Thank you for your attention. If you have a question, please let me know. Thank you.